Hey yo, this is a video of homework 44, proving quadrilaterals are parallelograms. In the first proof, we look at what looks like a parallelogram, but we have to prove it. So we have to go to 5-6 notes, and those are ways to prove quadrilaterals are parallelograms. So there's 5 ways to do it. You have to keep those in mind when you're doing this assignment. So the first step in this proof would be to write down the givens and write down one given and then look at it. So yeah, so angle WYZ congruent to angle YWX. All right, so what does that look like? WYZ, that's this angle right here, congruent to YWX, WX, that's this angle right there. Okay, so that looks like it's going to make this side parallel to this side because those two angles that are congruent are alternate interior angles. So let's look at the next set of givens. The next set of givens says W angle XYW congruent to angle ZWY. XYW congruent to ZWY, and it looks like that's going to make these two sides parallel with these two being alternate interior angles. Okay, so this is given. This is given. Okay, so it looks like for step 3 that XW is parallel to ZY, because if the alternate interior angles congruent, then parallel. Okay, so, and then the last step, not the last step, but the second to last step would be those other two. So WZ parallel to YX. And that is same as 3. Because if the alternate interior angles are congruent, then all lines are parallel. Okay, so that's it. All right, so 5 is X, Y, Z, W is a parallelogram, and that is because if both pairs opposite sides parallel, comma, then we have ourselves a parallelogram. Okay? All right, so not too bad, not too bad, not too bad. Okay, next problem. It looks like CD is parallel to AB. That's good. And then angle EDA is congruent to angle CBF. Okay. All right. Now, what that's going to do is make 1 congruent to 2 because these two angles are supplementary, these two angles are supplementary. So 1 is supplementary, 1 is congruent to 2 because angles that are supplement to congruent angles, like 1 and 2, are congruent to each other. Now, if we get 1 and 2 congruent, that's going to get this side parallel, or we're going to get these two parallel, okay? Or we're going to get these two angles congruent, this one and this one, all right? Not all right. Not all right. I need to back up, okay? So angle 1 and angle 2 are given that they're congruent. So then this angle is congruent to this angle, right? So we have to understand that these two angles are congruent. All right. Now, since CD is parallel, okay, to AB, all right, that makes this angle congruent to this angle. And that makes this angle congruent to this angle. All right. Now, these two angles are congruent by transitive property. And so both pairs of opposite angles, there's one pair and two pair, are congruent, making this a parallelogram. So let's back up. So this is saying that this is parallel to this. Okay? Well, we have a couple of transversals here. Now, this is a transversal and this is a transversal from these two parallel lines. And then we have the two angles. EDA is congruent to CBF. Now, that's going to make this angle congruent to this angle, and this angle congruent to this angle, and these two angles congruent by transitive property. And we're given angle 1 is congruent to angle 2, right here. So both pairs of opposite angles are congruent, making this a parallelogram. Whew. I sort of went in the wrong direction to begin with, but that's okay. All right, so let's lay it out. So 1, CD parallel AB, okay, angle, comma, angle EDA, congruent to angle CBF, and that's given. Okay, now what that does is make angle DAB congruent to angle EDA. And that is, if the lines are parallel, the alternate interior angles are congruent. Okay? And it's also true that these two are congruent. So angle CBF, I just stole it from this one, is congruent to angle DCB. All right, and that's the same as 2. And then that makes angle this congruent to this. So angle CBF, all right, congruent to angle, no, not angle CBF, my fault, angle DAB, this one, congruent to angle DCB. And that is by the transitive property. Number 5, okay, angle 1 congruent to angle 2, that's given. Okay, and I think that does it, because if both pairs of opposite angles are congruent, the quadrilateral is a parallelogram. That goes right to this, see? If both pairs of opposite angles congruent. That's the 5th one there. Oops. Okay, so that tells us that ABCD is a parallelogram. So if both pairs of opposite angles congruent, then we have ourselves a parallelogram. Okay? So we sort of rough start there, but that's it. Okay? Now, last proof is a bit of a conundrum, but it's not impossible. All right, so this is our first given, that we have this being a parallelogram. Okay, so that's great. Now, we also have MS congruent to TP. All right? Now, we also have angle RTP, okay, congruent to angle OSM, which is this one right here. Okay? Now, it looks like we can get this triangle congruent to this triangle by side angle side. So we have one of the given sides, okay, we have one angle, and that's given, and we also have these two sides because this is a parallelogram, so the opposite sides in a parallelogram are equal, okay? Now, we're going to say that after we prove those two triangles congruent, that this side is going to be congruent to this side by CPCTC, all right? And this angle is going to be congruent to this angle by CPCTC. Now, this side and this side are sides of the parallelogram. And this angle make these two sides parallel. Because if the alternate interior angles are congruent, then the lines are parallel. So both of these pairs of opposite sides will be congruent, or these two opposite sides will be congruent and parallel. Okay? So we got to get that done. So let's go ahead and do that. So we have number one, RSOT is a parallelogram. And that's given. And then the second thing we have is MS congruent to TP. And that's given. All right, and then we have angle RTP congruent to angle OSM. And that's given. Now, I could have put another statement in here based on this given, because I want to use the sides here of the parallelogram, but I'll do that in the fourth step. Okay, because I want to get the two triangles congruent by side angle side. So 4 is that SO is congruent to TR. And that is because if I have a parallelogram, opposite sides congruent. Okay, so now the two triangles, triangle RTP congruent to triangle OSM by side angle side. The first side is given. The angle is also given, step 3, and the other side is 4. Okay, so now we got a couple of CPCTCs. MO congruent to PR by CPCTC. And angle R, angle PMO, or SMO, I guess I could say. Angle SMO congruent to angle, is it TPR? Yes. And that is CPCTC. Now, I'm almost out of time here, so CPCTC, you'll have to finish this proof on your own. Okay, I'm going to stop it and then put the last step down. So the last two steps are MO is parallel to PR, and that is if the alternate interior angles are congruent. And the last one is we have ourselves a parallelogram because one pair of opposite sides are congruent and parallel. Okay, that's it.